Okay, this is the final tutorial for your findings, and it's entirely optional. In the previous tutorial, I will have suggested you might want to use this tutorial if you want to further your analysis by using statistics. This is also something I mentioned in the part 2 of the data presentation findings when we actually developed the scatter graphs. Right, if we have a look at the original instruction document, which we've been using, the first section of your findings is your data presentation, and you will have created a long profile of the beach that shows the changing gradient, underneath which you will have placed a graph showing the changing pH of the soil as you moved further away. Above them, you may have placed the diagram, this one here, or one of these, and lined it up with those graphs so you could actually see what the theoretical beach and how it compared to your data. In the second set of graphs you produce, you'll have done some scatter graphs. At the very least, you'll have a scatter graph which allows you to see whether there is a relationship between the distance from the sea and the pH. But you were all suggested to do at least one scatter graph that maybe tests the relationship between the pH and another variable to see if maybe the number of species or the amount or lack of grass or vegetation was in some way influencing the pH as well. Now, in the third tutorial, you were shown how to both describe your results from the graphs that you have included, and then how to explain them. So that is where you are linking the changing pH both to the theory from the background research, so these graphs here, as well as linking your results of your pH changing with another thing apart from, for example, the number of seashells, calcium carbonate in the soil, and the fact that's decreasing that strongly influencing pH. You will have hopefully made a link between one of the other variables, that the percentage of the soil covered in sand or with no soil and with no vegetation, or the number of species might be playing a factor. Had you found a relationship there? And all of that should have been explained, as well as, and most importantly, any anomalies that you discovered. So that's indicated there. So there was that steep drop, and you'll have probably identified that behind the yellow dune, there's a noticeable drop in pH, as well as that slight rise, and that happens to combine largely with the dune slacks. And you might have thought about explaining why the pH dropped sharply behind the sand dunes, but why it increased again when it was in the dune slacks. That was the area below sea level that was a bit marshy and swampy. Okay. Right, what are we doing in this final? Because I've spent quite a bit of this tutorial already just sort of saying where you should be at. In this final one, you're wanting to do a last piece of analysis, which is linked to your scatter graph. Because the problem with analyzing a scatter graph is, whilst it does show that there is a negative relationship between the two variables in question, the pH of the soil, when it's high, the distance from the sea is low. And as you move further away, as the distance from the sea increases, the pH drops. Okay, and you might have seen a similar pattern, might have been positive or negative, in when you compared your pH of your soil with, which will probably be your x-axis, with one of the other factors that I suggest you look at. But this is just visual. This is you just saying it looks like there's a strong negative because most of the scatters are near the line of best fit and they clearly have a downward trend. There is, however, a mathematical way of proving whether this relationship exists, and I'm going to show you it. And there's this little number up here, and I'm going to show you how to create it, and I'm going to tell you what that number means. Okay, so we're going to do some statistics. Now, at this stage of the geography course, as you do this, you don't need to know much about statistics. One thing you do need to know is that spreadsheets, like Google Sheets, can do some mathematical calculations for you. They save you doing the maths. All you've got to do is understand what it is you're doing, why you're doing it, and then interpret the result and use the result when you're writing up your results. It is by far the best thing, if you can do it, if your data allows you to do it, to use statistics to prove something, to prove, in this case, possibly a hypothesis. Not to just say the data seems to suggest that I can prove my hypothesis, as you move away from the sea, the pH drops, but actually the mathematical test mathematically proves it. And that's a much stronger level of evidence. So let's have a look at how we do this. The first thing you want to do is select your two variables. Before we do that, let's actually start the statistical process. So there's a little button over here, and it's this one here. It's called the Functions button. When you click it, if you go down to All and hover over that, it'll bring up a sub-menu. Now we want to scroll down to the letter P because the statistical test we're going to use is called the Pearson's test. Now this is one of the statistical tests. You'll have never come across it before. And it's used to basically mathematically prove whether a scatter graph is showing you a positive or negative relationship and just how strong that relationship is. Okay? And when I say relationship, whether the two things are linked. Does the distance from the sea affect the pH of the soil? So it's now brought up. I've selected a cell, by the way. I clicked into a cell. I selected the Pearson from this menu. And here we have, it says equals Pearson in capitals, and there's a little brackets. Now what I'm now going to do is select my two data sets. So column F, my distance from the sea column, which is called total horizontal. I'm just going to drag my mouse from the top to the bottom of that cell. And over here we can see it's said F2 to F27. And it's column F, row 2, all the way down to row 27 in my spreadsheet. I now want to select my second thing, which is pH. So I'm going to go to H2, hold my mouse down, button down, and drag it down to H27. And you can see here we have H2 to H27. Now what you'll notice has happened is I've not hit the CTRL button. So I'm just going to delete that, hold down my CTRL button now, and do that again. And this time, if you remember from the data presentation tutorials, it allows me to set two columns that are not joined together. And there they are. Okay. All I'm now going to do is hit the enter button. Right, and that's going to give me a number. Now that number at the moment, if we just zoom in, will probably mean almost nothing to you. Okay. So I'm going to tell you what that number is and then how you will write up that number in your results as the very last thing that you do. So the first thing this number does, this number will be anything between -1 and +1. So it covers a range anywhere from -1 to +1. The nearer this number is to the 0, so 0.0000, the more likely there is absolutely no relationship between the two things we're thinking about. So if this number had been 0.000, that would basically mean that as you move away from the sea, or the distance from the sea has no influence on the pH of the soil. If this was a number 1.0, not minus, but plus 1.0, it would mean there's a perfect positive relationship. What that means is every time I move a bit further away from the sea, the pH would increase. So as one number gets higher, the other number gets higher. So as my distance increases, my pH increases. And if it was a number 1, that would mean there's a perfect link. At every location, the pH is getting higher. Likewise, if it's -1, that means every time I move a little bit further away from the sea, my pH gets lower. So as one number gets higher, the other gets lower. Now you'll notice -0.84 is actually quite close to -1. It's closer to -1 than it is to 0. And what that tells me is I have a very strong link between the distance and the pH. And because it's minus, it tells me as I get further away from the sea, the pH is decreasing. And I can be mathematically very confident that's the case. So the first thing I'm going to write after I've written about my scatter graph. So when you've written your results about what your scatter graph showed, your scatter graph seemed to suggest a strong negative relationship. What you then want to do is say that using a Pearson statistical test, a result of -0.8, and I'm just going to round it up to 5, so -0.85 was recorded. This result suggests that there is a very strong negative relationship. Okay. Now let's go a little bit further because we're not actually finished, because there's another stage. How confident are we that that number is correct? Okay. Now there's one final step we've got to do to determine how confident we are with this -0.85. Let's just reduce the size again. What we need to do is actually find out the confidence level. So I'm going to go along here and find that I had 26 locations where I recorded the pH and the distance from the sea. So there were 26 sites as I moved away from the sea where I stopped and got the pH. Now that's important. I need that 26. It's what's called my N value. It's the number of data sets I've got. And I'm going to go to a critical values table. You don't really need to know what that means at the moment, but oh, there we are. For this, I need one of these, a table of critical values for the Pearson correlation. And I'm going to ignore this thing at the top. I'm going to look at here. Here's my N, and I'm going to go down to 26. Now, if I have 26 pairs of data, so I went to 26 sites where I got the pH, and the number I record, that Pearson's number, remember that minus 0.84, if that number is bigger than this number here, then what that actually allows me to say, by the way, I know a minus number is not bigger than a positive number, this is a positive number, but you can imagine that this is also a minus 0.317. So minus 0.84 is actually larger than this. If I go to the top, you'll see it says 0.1. Now what this 0.1, this is what we call a significance level. And if I can get a number that's bigger than this significance level, I can actually say that my result is significant. And if it's bigger than this number of 0.1, I can say it's significant to the 0.1 level, which means I can be 90% confident that my results were not by chance, that they are actually accurate, that as I move away from the sea, the pH is falling. Now, if we go back down to the 26, we actually find that our number is bigger than the next two. Our minus 0.84 is actually bigger than this one, and it's actually even also bigger than this one. So let's go back to the top. Now, this significance level is 0.01, and that's even better. Basic way of saying this, if my number can be bigger than this, then I'd like it to also be bigger than this, and I'd like to actually be bigger than this number, the third number, because what that means is that it's not just 90%, I could be 90% sure that it's not a random by chance, that actually that there is a relationship. This one here, by the way, is 95%. This one here is 99%. So what that really means is that I'm now 99% confident that my data, my results, weren't by chance, that actually there is a very strong negative relationship. So how would I write that up? Because I've already said that there's a strong negative relationship. I would then say, furthermore, as my result of minus 0.84 is greater than the critical value for an N of 26, which is at the 0.01 significance level, or of and 0.479, I can be 99% confident that my results were not random. Final thing to say here is that you've got then very strong supporting mathematical evidence to reject, to accept the hypothesis that there is a relationship between the distance from the sea and the pH. Now, I know you've not done any statistics yet, and it takes a bit of practice to do that, but if you choose to write that up, write your results up this way, and report everything in the way I've described it, an examiner would be looking at it very favorably, because they know that you've gone beyond the simple use of scatter graphs and line graphs, but actually you've used some mathematics, and you've understood the result of those mathematical tests to report your findings. Okay, if you get very confused by this tutorial, then what I suggest is you don't go beyond tutorial, the first of the analysis tutorial, part 1.